Alright, what's up guys? In this video we're going to pick up with some multivariable calculus. Going to be talking about tangent vectors. So as to solve the following problem, we're given the following parameterized curve. They want us to find the unit tangent vector at the given value t. So this is the parameterized curve here given by r of t, and t is equal to -1. So all we really need to do here is use the definition for the unit tangent vector. So let me remind you of what that is. So recall the unit tangent vector, that's just t of t, is equal to the first derivative of the parameterized curve, all divided by the magnitude or the norm of the first derivative of the parameterized curve. And in our particular case, we have t is equal to -1, so after we take our first derivative, we'll plug that in there before finding the norm or the magnitude. You won't always be asked to substitute in a value. They may just ask you to find the unit tangent vector given a parameterized curve. They may not always give you a value of t to plug in, so but in this particular case they are, but they won't always ask that. So let's just get the first derivative out of the way. So we'll take the derivative of each component of this parameterized curve. So it looks like we'll get 16. Well, -3 is a constant. Its derivative is 0. Then we need the derivative of 8 over t. Well, the derivative of 1 over t with respect to t is -1 over t squared. So if we multiply by 8, we get -8 over t squared. And remember that t was equal to -1. So let's go ahead and plug that in there right quick. So we need r prime of -1. Okay. And we need to see what we're going to get. So clearly here we're only going to be substituting in the value t in for the t on the last part here. So it's just going to give us 16, 0. Then we stick in a -1. That's going to give me a -8. So that's what we get when we stick in the t is equal to -1. Now we need the magnitude of the first derivative of r prime of t, but in this particular case we needed to substitute in the value -1. So it'd be r prime of -1, or the first derivative there, and it's just the square root of the sum of the components squared. So it's going to be 16 squared plus 0 squared plus -8 squared. You don't really have to write 0 squared, but I'm just doing it for the purpose of the video. Now we clean it up. 16 squared, that's 256, plus 0 plus 64. That's going to give me 320. Okay. Now you always want to try to do prime factorization and simplify things down as much as possible. So that's what we're going to do here. All right, 320. So okay, well, 320, that's going to be 2 times 160. 160, that's 2 times 80. 80 is going to be 2 times 40. 40 is 2 times 20. I'm going to go over here. Let me go over here. Break this 20 down a little further. So 20, that's 2 times 10. And I can break down 10 a little farther. That's 2 times 5. So what we do is we count how many 2's we got right quick. I'm just doing some prime factorization. So we got 1, 2, 3, 4. Well, this was just an extra one. I had to bring it up on a paper because it didn't fit. So just to eliminate confusion. So we got 1, 2, 3, 4, 5, 6. So we got 6 2's. So this would be 2 to the 6th power. And it looks like it's going to be 2 to the 6th power times 5, which is the exact same thing as this. Now we can break this up as the square root of 2 to the 6th power times the square root of 5. 2 to the 6th power is 64. So that'll be the square root of 64, which is 8. So if we do prime factorization, we'll get 8 times the square root of 5, which is, if we do prime factorization, we'll break down the square root of 320 to be that. Okay? So the square root of 320 can be written as 8 times the square root of 5. Alright, now we need to substitute in and simplify. So our unit tangent vector, it was t of -1, and it was r prime of -1 all over the magnitude of r prime of -1, or the norm. And we're just going to have 16 comma 0 comma -8, and then we'll divide that by the magnitude of when we took our first derivative, we stuck in a -1, and we just computed the magnitude of the norm. That was 8 times the square root of 5. So let's simplify this and we'll get our answer. So your final answer here, our unit tangent vector at the value t is equal to -1. Looks like t of -1. Looks like it's going to be equal to, if we simplify, 16 over 8 times the square root of 5. I can write that as 2 divided by the square root of 5. Typically you don't want to leave square roots in the denominator, but we're not going to worry about that in this video. And obviously here we just get 0, and this will just give us -1 over the square root of 5. So that is going to be your unit tangent vector at the value t is equal to -1. Alright. So let me know if you guys have any questions about this. I'll be more than happy to talk about it. So I'll see y'all next time.